Welcome to Magic. So today we are going to do the standard integral, and then we might go to prove some give more general formula. Okay, but then we first start to compute this. So in order to compute this, then we use a double integration into this. So notice that we use polar coordinate. So remember that ds dy will be rd theta. Okay. Okay. So now you know that our integration part is the infinite region, infinite radius circle. So and this theta is 0 to 2 pi, 0 to pi over 2. So this integral is fairly easy. That we just change it to from r to infinity 0 to 2 pi, to pi over 2. Okay, so we have pi over 2, 0 to infinity exponential minus r squared r dr. And notice that this is the r squared and half. Okay, so we have 4 pi 0 infinity, right? And this can be done because this exponential x minus x differentiate just exponential minus x to the power x. So this is just pi over 4. And maybe from infinity to 0. So infinity is infinity when 0 plugging is 1. So it's 4 pi over 4. So we have 0 infinity exponential minus squared 4 pi. And then you get this. Oh, sorry. Okay, so this is our result. Okay, and the second, some people will see this as exponential minus infinity to infinity and exponential minus x squared dx. Basically, this is just 2 times 0 to infinity exponential minus x squared dx. So basically, this is pi. This is also very standard. Okay. And the third is that some people will see this. There are some 8 which is larger than 0. And basically you just use the change of variable. Then you change ax squared ax to y. You plug in. Then you will see this just base y squared. And the dx is just square a dy from 0 to infinity. Square a and pi over 2. So basically just this one. Okay. Okay, and the next, some people will see some general problem is like maybe there's s squared here. S squared exponential ax squared dx. Okay, and how to do this? Okay. Basically, this is very somewhat technical, but from here we have 0 to infinity minus a exponential minus a squared dx equals to pi over a. And we differentiate respect to a. And we have notice that with respect to a, so we have 2x squared dx will equal to, so basically this is a to the negative half, and then we differential respect to a. So we have this one. So there's a one half, negative one half will one negative half will show up, and then we have this. Okay, and finally we have this result. Okay, so this is our result. And basically, you can use this method to get the standard this one. If n is an integer, you can calculate this interval by just keep differentiating with respect to a, and you can get an answer. So I leave as exercise for you guys. So this is our this video today, and I hope I can see you guys in the next week.